Okay guys, so let's start what is shear center. So this video is going to be about 5 to 7 minutes, that's all, because here I have contained a lot of gate questions, all kinds of topic related to shear center. Okay, so we'll start with very basic. It is a point through which applied, or you can say external, shear force produces no twist or no torsion, but it produces only bending, or you can say pure bending. Let's see what is the meaning. Suppose this is I have tried to draw 3D beam. Okay, like this is the length of the beam and this is the cross section of the beam here, this white color. Okay, so suppose you have a shear stress. I am saying shear stress. Suppose you have shear stress. Basically we use symbol tau, and definitely it will move like this, correct? So suppose you have shear stress in the beam. Okay, so you see this shear stress is going in this direction and this shear stress is going in this direction. So this direction and this direction shear stress will give you a resultant shear stress which will be in this direction, correct? I hope you're trying to understand. Okay, I'm just saying shear stress is in this direction, shear stress is in this direction in this beam, so resultant of these two will go in this direction. Okay. So if you will apply one extra load here, exactly at this point, if you will apply any extra load here, okay, let me change the color, take white. So apply load exactly here, then this load will vanish the resultant shear stress, correct? Okay, so because this is a shear load which is able to vanish these two shear stresses, so effect of this twist will vanish, correct? And it is acting on this point, because suppose you have channel here and you have shear stress here, like this, flow is like this, shear stress flow. So at this point, one was in this direction and one was in this direction, correct? So resultant of these both will be in this direction. So now I am saying applied any external load. This load has to take care two things. One thing, the resultant shear force which is coming from because of this and this. So after the application of this force, it should be vanished. I mean total effect at this point should be 0. Okay, I mean total force, resultant force after applying this should be 0. And the next point is this and this, they are producing a twist like this. So if you apply a shear force like this, so this will apply a twist like this, so twist will also get cancelled. Okay, so at this point where this phenomena is being possible, that point is shear center, that's all. That point is shear center. Let's see one more example. Here you will be more clear. Suppose in this channel you have shear force, shear flow is like this. You say shear force or shear flow, you can say shear flow is like this. Okay, so suppose from here you have shear force in this direction and here you have in this direction. Okay, and in this one, I mean in this beam, it is in this direction. Okay, fine. So if here you want to vanish the effect of twist, because why? How effect of twist is coming? Because this force and this force, they are producing effect of twist like this, correct? So this beam is having tendency to twist like this. I hope I'm being clear. So now I'm trying to say, if you want a force to apply to vanish this twisting effect, then definitely you should apply that force in such a way twist should come in this direction, correct? Okay, now you have to think where to apply that force. You will apply that force here or here or here or here or where. Okay, so or like this or like this or like this or like this or like this, and these shear stresses what we are going to apply, they will be shear force, okay, of shear nature. Okay, so let's start how to think on this. So here this force and this force, they are cancelling each other, correct? But they are not cancelling their torsion, correct? Twisting effect is still there. This direction and this direction, force is being cancelled, but twisting effect is still valid, correct? It is kind of couple, right? Couple. Okay, twisting effect is there. So you have to think this force, okay? These forces are vanishing each other, no problem. These forces are balancing each other, no problem. Now we have to think only about this force, only about this force. So now we don't have to apply forces in this direction, correct? Now we have to apply forces only in vertical direction, because only vertical direction forces can vanish this force. So now our job is to think direction. We got it. Our direction is very clear now. Our direction is downward, but where? So the where question is where. That where means we have to take care of anti-clockwise twisting moment, right? Because this guy and this guy is producing clockwise, so our this force should produce anti-clockwise. So definitely anti-clockwise means where is the location? Definitely this is the location, okay? Because this force, I mean, exactly, if you apply exactly over the section in this direction, it will not produce any twist. This guy will again produce twist in this direction, so it will be supportive for them. So definitely only this guy will produce twisting in this direction. So we got it. Means for this beam you are going to apply eccentricity, I mean you take some eccentric distance and there you apply the shear force. So if you will see from the front, so I am drawing the front view of this beam, so you are going to apply here. So this will be your eccentricity. It is actually very easy. You see this shear force will pass through this point, okay? And now here where will be your shear center? So shear, you draw one symmetric line which will divide this body equally into symmetrical bodies, okay? I mean this body is symmetrical about this axis, correct? So draw one axis line. So this point will be your shear center, like action of this line, action of this force, and this point. I hope you are being clear, okay? Now I will give you one idea. The given channel can have two type of symmetry. Here I have taken I section. Channel looks like this, okay? This I section. So you see this first I section is having two axis of symmetry, okay? So shear center will lie on centroid of the given section, exactly. Not only for I section, even if you have some plus section which is properly symmetric about this line also and this line also, then shear center will lie here. If you have a circle, exactly, then it will lie here. Even if you have elliptical shape, the shear center will lie here, okay? Okay, but you see the second I section, about this line your I section is symmetric, but about this line your I section is not symmetric. So this is only one axis symmetry. So shear center will lie on the axis of symmetry but not on the centroid. Same happened in this case, correct? Same happened in this case. In this case same happened. This is only one axis symmetry, so shear center will lie somewhere but not on centroid. So shear center location was this. I hope it's clear. So that's why we give the definition as it is a point through which applied, or you say external, shear force produces no twisting. Why no twisting? Because that should vanish the twist, correct? But only bending occurs, that is pure bending. Let's see some gate question, very interesting gate question. In GATE 2014, they asked directly this question itself. The possible location of shear center, which is highly easy. This is the possible center, right? So P is the possible location. Now next, GATE 2019 question. For a beam subjected to transverse shear load through its shear center, then we have four options. They are saying we have a beam. Over the beam we have a load acting, and that load nature is transverse shear load, and then we have to choose the right option. So, and the load is acting on shear center. So what will happen? So definitely if load is acting on shear center, then the twist per unit length is 0. I mean we don't have twist, correct? We will be having moment but we will not have twist. So option A is correct. Let's read option B, C and D, because I'll explain something. The shear stresses is uniform throughout the section. Yes, shear stress can be uniform. Make sure what is 0. Twist is 0. Shear stress can be there. I mean to say, suppose you have a beam here. In this beam you can have shear stress. These lines are shear stress only, right? So shear stress can be there, no problem. Why option C is wrong? Bending stresses are 0. No, bending stresses are not 0, because if you will apply the load here, then entire beam will bend like this. Bending stress will produce. Okay. Option D, the shear strain is 0. No, shear strain will not be 0. Okay, because strain is about deformation. Okay, even bending can produce shear, that thing, strain. Okay, so this is how we are clear. Option A is correct. Only twist is 0. And this is a case of pure bending. Whenever you applied load on the shear center, it will go for pure bending. There is one more question. They are important questions, and from shears, this topic they ask very easy question. You will be able to crack. The point within the cross section plane of a beam. Okay, the point within the cross section of a beam through which the resultant of external loading has to pass through. To ensure pure bending without twisting, try to get section of the beam is called shear center, because at shear center only we don't have twisting, we have pure bending. Okay, so option is clear. I hope this video is helpful for you, and if you want to purchase material for GATE exams, you can visit our website, go to the description, you will be getting a lot of things there.